Okay, so this is resistors in series as well as parallel. So we are going to look at the equivalent resistances or the net resistance of resistors in series as well as the parallel resistor. So just like the cells, we can see the arrangements here that they are connected end to end. So that means that when a current flow from this resistor to this other resistor, the same current flows through them. So, and because the same current flows through them, so what that means is that the current here passes through R1 and also through R2. And what makes current to flow is because of the potential difference. So for current to flow from point A here to point B here, that means that the potential at R1 is different from the potential across what? R2. And that is the reason why current can flow from here. So if we don't have potential difference between R1 and R2, that means that current cannot actually flow from A to B. Now, how do we now get the overall resistance of the resistors or the net resistance of the resistors when they are combined in series? So what we are saying is that because of the potential difference between the two ends of the resistors, so we are going to use that following the Ohm's law to the expression for Ohm's law to generate this expression. So now look at the current here. Now, the same current passes through the two resistors, like I have said, and then the potential difference across R1 is V1. The potential across R2 is V2. So that means that the potential across AB is going to be the total potential. So let us represent the total potential across AB to be V, and this is equal to V1 plus V2, since the V1 is potential across R1 and V2 is the potential across R2. So that means that when we total the total potential across R1 and R2, that gives us what? The total potential that across AB. Now, we know that potential is actually current um, times resistance. So I'm just trying to say from here that the potential across here is from Ohm's law is I R1 plus what? I R2. So I'm talking about potential across this one is current times the resistance R1, and then current across potential across V2, which is V2, is current times what? R2. Okay, and that is V total. Now I want to factorize this. So factorizing this, then I have I in bracket R1 plus what? R2. Okay, so I just factorize this to have this. So we can actually divide both sides by I. So, and then we have here, this cancels out this. But we already know that V over I is equal to R from the Ohm's law. And that gives us what? R1 plus R2. And this is the equivalent resistance of resistors in series. So this is two resistors in series. The combination is just simple like this. Now, how do we solve problems like this? If actually we have a problem, let's say two resistors connected in series like this. So assuming we have 2 ohms here and then 3 ohms, they are connected in series. So how do we find the equivalent resistance? So already we have here that R total is equal to R1 plus R2. So that means that for us to solve the equivalent resistance here, we'll just do R is equal to 2 plus 3, and that gives us what? 5 ohms. And that is the equivalent resistance of resistors in series.